A speaker here on stage. Please welcome Huawei's Chief Expert Standardization of F5G and ETSI ISG F5G Liaison Officer. I love this job title. A very warm welcome to Dr. Marcus Brunner.
Thank you very much. I love the job title as well. Yes, so you heard a lot about the F5G already. I show you a little bit the F5G standardization landscape, and then a bit on the evolution and a little bit on the technology behind those things. So that's where we are. The first slide is always, and I've seen that now in almost every talk in the FTTH council meeting, fiber is energy efficient. Yes. I mean, I just put in here from the Federal Ministry of the Environment of Germany. They did really experiments, and it shows that fiber optics is far, far, far lower energy consumption than any of the other technologies. Against cable, it's still okay. Against some of the mobile technology, it gets really, really bad. Also note that 90% of the traffic in Europe is carried by fixed networks. It's a bit against the mobile guys here, but fixed networks are the workhorse of our internet. So that's why I like to be in that field, and I like to look into the fiber aspects. So F5G, you heard already about F5G. Why the hell did this guy talk about F5G? So first of all, it really is defined by the ETSI, the European Telecom Standards Institute. It is a group there with just all that definition and standards. Why we have chosen F5G is because we basically see the same trend in fixed as in mobile. You see several generations on the mobile here on the top, and we basically have similar generations of fixed networks at the bottom. And what we have now in F5G is this having multiple services, multiple applications, multiple industries needing this type of infrastructure. That's why you have this plethora of different industries and applications here. From a technology perspective, F5G as such is Wi-Fi 6, 10G-PON, 200 gig per lambda WDM. That's sort of where we are. We basically defined F5G as three-dimensional space, having enhanced fixed broadband, having guaranteed reliable experience, and having a much higher density of connections and fiber endpoints. So the whole logo of F5G is fiber to everywhere and everything. Means a lot more fibers being there. So we talked about F5G, that's sort of where we are now. Now let's talk a bit about the future. And this F5G evolution, why do we need that? There are several trends, and I have another slide on that as well. So we have this trend from having human-to-human connections to human-to-machine connections, having full connectivity. We basically want to have a much higher reliability. We need to be more green and more efficient on the connectivity side. So basically, we extend this three-dimensional space into a six-dimensional space. We naturally increase speed, so enhance broadband. I mean, speed is always important, but it's not the only thing. We still increase the number of endpoints. We don't have only fiber to the room, but we have to the machine, to the robot, to IoT devices, and so on. And the experience is naturally a way to improve. But what we add here is three additional dimensions, and already with my introductory slide, it's the green aspect is added. So having even more greener technologies in fiber. Even fiber is green already. We want to do it even greener along the way in the future. We look into real-time resilient link. That's where we really start applying optical communication, not only for residential use, but that's we do run projects now for factory manufacturing and the fiber to the robot and fiber in the robot type of aspects. So this is sort of like a future-looking thing in that sense. And we don't do only communication, but we also start using fiber for sensing. And if you do both, it's very good to use the same infrastructure. From the characteristics, we believe it's sort of, we just heard in the previous talk, the 1 gigabit for the user area. Here in this evolution, we start talking about the 10 gigabit. We don't do only carrier, we go into industry. We go towards sensing, and you already heard, for example, the ALPS WDM solution we just shown. We move from electrical to optical only. This is sort of the future trend going forward. Now, there are basically two drivers. One is the digitalization, cloudification of applications, and the other driver is just things in the network infrastructure we need to look at. So these are sort of the two major trends we are looking into. On the network side, it's more smart, add computing, have autonomy, 0x, self-x, being more green, and having sensing capabilities. That's sort of the infrastructure part. The drivers on the cloudification application part, already talked about, fiber to the machine, digitalization, one hop to your cloud. If you start looking into immersive HD applications, you need 10 times bandwidth. If you go metaverse, you need new capabilities in your network. So these are the drivers from the application and the infrastructure side. And then I have listed here a whole plethora of enabling technologies. And you have seen some of them already in the previous talk. I don't want to bore you with all of the technologies, but I want to go into two particular ones. The FTTR, the fiber to the room, and the 50G-PON. I do a bit of detailed look into those two aspects. But you have seen the overall picture is really F5G is the end-to-end optical network, and we look into the evolution of that. So we have three challenges to be addressed in the 5G deployment, 50G deployment. I get too many G's now. In the 50G deployment. So we basically need to keep the ODN. So because the cost of building up the ODN, so the physical fiber infrastructure is very expensive. You see some numbers, some operators have even higher numbers on the percentages. So we need to be compatible. The second thing is there are ONUs out there for some time, and they will stay there for some time. So we need to be backwards compatible with them. Specifically, that means we need to be backwards compatible with GPON and 10G-PON users, and that we can smoothly upgrade them. So we need to have this compatibility. And then we want to basically reduce the initial investment. 50G-PON today, I don't think many people want to have a mass deployment of 50G-PON today. But it's a gradual way of improving your network over time. If you have an application, if you have a customer which needs it, you do this gradual upgrade of the systems. So basically, how do we do that? And the 50G-PON solution from Huawei basically is looking into that with these technologies. First of all, using the existing ODN, basically our 50G-PON port has now digital signal processing for processing the optical signal and has optical component. If you do that in a good way, and there's a lot of engineering and IPR behind that, you can achieve the 32 dB optical budget, which is the current standard for ODNs. So basically, you can reuse the ODN as is. No need to change at all. So there are a set of innovations here, and there are a set of algorithms needed, and I have a bit more on that. On the reusing of the terminals, like we know it already today, what you guys, I guess, have deployed is GPON, 10G-PON combo systems. So there is no reason why we should not do a combo system with 50G-PON. So we do have, it's a triple coexistence, is standardized by ITU. So we have triple coexistence of the different GPON technologies on the same ODN. That basically means the replacement of the ONUs can be gradual as needed. Basically, you can use whatever PON ONU you want. And finally, the old chassis are still reusable. That's also from an energy and a life cycle perspective very important. You don't want to kick out things which work quite well. So there's the 8-port 50G PON cards, the first one being symmetrical in the industry. So you can use this 50G PON 8-port card in existing MA 5800 chassis. And basically that allows to protect your investment, which has already been done. It's multi-platform, it's rapid deployment, it's just about putting in a new card, and it improves your competitiveness in the market, in case you need that capabilities of 50G PON. A bit more on the deep down in the technology. I already shown you the port here. On the optical side, we basically have a special amplifier here, which basically is very concentratedly send light down the fiber. I don't want to go into detail, but this high amount of power in the density, it can be comparable, or the number is 200 gigawatt per cubic meter, which basically would mean comparable if you have one light bulb, it would light up the Real Madrid stadium or 2 football fields. So this is just to give you a bit of an impression how much power there is. I mean, it's very small. It's not, with the fiber we cannot light up that, but it's about the density which is used here. On the receiving side, we have nanoscale material, which basically is able to fully capture the protons coming down the fiber. So that's a very special material. This material is also used in space telescopes. It's basically based on reflective coating. So this is special material on the receiving side of the PON, which basically allows you to have the conversion efficiency going from somewhere in the 70% to the 100%. You receive every photon from your fiber. On the DSP side, the DSP is basically improving transmission, and we are basically to increase with special algorithms in the DSP, we're able to increase the optical power budget by 3 dB. There are basically 2 aspects here. Don't want to go into too much detail. One is the algorithms, how you do the decoding. Basically, that one gives the 2 dB, and you have the LDPC, which introduces a sort of like looking into the waveform, getting that waveform back, you get 1 dB. Plus, we have special mechanisms to increase the efficiency, because we are basically able, in the start of a PON frame, the PON frame can be much smaller, basically meaning you have more payload, which basically allows you to have much larger payload, somewhere increase the payload by 30%. So that's different technologies to improve the efficiency of 50G PON. Now coming to FTTR, let me make a comment to the FTTH Council talk before. I think they really need to change the name. Fiber to the home, I don't think fiber to the home is really timely anymore if they want to look ahead. So we coined the term like fiber to the room, and the system of the fiber to the room, you have seen almost all of it already. Just 2 aspects is we basically have applications on phones, which is sort of talking with the fiber to the room management system to basically get your whole home being covered with very good quality of experience. So that's sort of a bit of the management aspect. And then basically what you need in your home, you have a lot of different applications meanwhile. You cannot imagine what is there already and how much will come over the next few years. So basically have a lot of different connections, a lot of different devices in your home, so you need to be able to cover that up. So again, bit more technology. Basically what we had today was a normal PON chip. Now for this particular solution, which is very good in the very high-speed space, and you see we are up to 2 gig per, for that system. we basically added here network processing, and we added algorithms for making it more clever and smarter. So that's how we achieve this type of things. So this is a particular 10G-PON chipset enhanced with additional algorithms. On the Wi-Fi side, we basically are able to, with intelligent DPD, we are able to gain another 2 dB, which basically increases your either the speed or the coverage, depending on what you need. So these are sort of these technologies which allow to have this industry-first all-optical 2 gigabit Wi-Fi to every room. And it's really useful for using that in the homes. A few more aspects. You typically have roaming in your home. Not sure how many people walk with a video call, but for sure with WhatsApp call or IP phone calls or whatever you walk around in your home, that basically is blocked. Most of the today's system basically have an access point, you connect to that, and then it needs to reconnect to another access point. The Huawei solution is basically talking about the seamless roaming, and we can do that because we have a coordination function in the main ONU. So you have a particular main ONU, and you have several satellite ONUs, and basically on the coordination of all of that happens centrally. That's why we basically can do that. And that basically shows you here just like visualization of it, that you can walk with your, it's again video call here, but you walk with your video call, this access point has it, then there's a handover to the other access point and to another one. Through the centrally algorithms, we are able to do the handovers in 20 milliseconds. 20 milliseconds is far below the 50 millisecond SDH handover time for voice networks. So you don't really feel that anymore. The last topic is, here we basically have using a bit of technologies from the 5G technologies. In the industry today, is the sort of the usual access point has 2 horizontal omnidirectional antennas. Huawei, and then what you get basically this picture on how this looks like. You have an access point in the middle, and it sort of goes around in a donut. The Huawei solution is basically adding 2 vertical omnidirectional antennas, and the horizontal ones are multi-beam. You basically get something like that. You see you have the much better coverage in the 3D space. Why is this important? You don't have Wi-Fi only on one space. You have Wi-Fi equipment down, you have Wi-Fi equipment up, you have Wi-Fi equipment everywhere. And we basically allow to follow devices. So that's where sort of mobility for one access point, and to keep the quality of experience, you basically have this beam-forming thing. The beam follows your device, no matter where you go. Finally, if you have multiple access points and Wi-Fi as such, today it basically has collisions. If 2 or 3 people want to attach to the Wi-Fi and send, there needs to be some sort of coordination. The Wi-Fi standard as such just gets a collision, and then somebody is backing off and sends again. But with the coordination, again, the centrally located coordination, we basically can have a coordinated way. You have different streams. You can have quality per stream. And the last thing is, sort of in industry, the average number of concurrent connections in a Wi-Fi access point today is 32. You say 32 is a lot. I go back home and count how many Wi-Fi elements you have. 32 might be a lot today, is not a lot next year anymore, or in 2 years. So that's why we need much higher numbers here to have. This solution now is 128 concurrent connections, which are stable and high quality. Coming to the end, to sum up, so F5G and its evolution is really targeting the twin transition for green and digital transformation. we have this fiber to everywhere and everything. We basically move from copper or wireless to fiber. That really saves a lot of energy, if you look at it. The digital inclusion is higher, because you don't need all these special things. So the F5G networks can be deployed relatively cost efficient. You have seen the fiber to the room is sort of like a first embodiment of the fiber to everywhere. If I heard fiber to the room first time, I was like, what the guys are talking about. But now it's reality. On our booth you just heard, I think it's the most seen exhibition in this event at Mobile World Congress, wherever you go. It shows a lot of interest on that. The digital transformation with having very good home coverage, very good quality of experience at home, it basically increases the digital life. You have a lot of applications which need that. Think about education in rural areas. Think about your team's conference calls while your kids are playing games. So having this remote capability of doing your work is very good. And it's also, if you don't go to your office, it also saves the gas in your car. And it naturally, with that, improves the economic efficiency. There are studies in the ITU which show that there is the direct linkage with fiber build-out and the economic efficiency. Finally, fiber is already green, but we naturally need to make it more green. There's no way around that. We basically try to improve the technology on the optics side for having much tighter integration of optics and IT things. And we need to look into power-saving mechanisms. Where can we still save some more power? And with that, I thank you very much for your attention.